Hey everyone, welcome back. We are going to look at lesson 4 in our workbook today, and it's kind of exciting because we get to look at a new kind of function, something called a logarithmic function. So we've covered exponential and we reviewed our exponent laws, and we looked at the graph of the exponential function. So we're just going to delve into a little investigation here. So the inverse of y equals 2 to the x, remember doing inverses from the functions unit, we find the inverse by switching x and y. So in that function, y would become x becomes y, and that would become x equals 2 to the y. So now, usually you try to solve for y on the next step, but let's see. We sort of have an exponential equation, but all we've learned so far is how to get the bases the same, and there's no way x and 2 can be the same base or the same number. So I guess that's where that one stops. So right now we can't actually solve for y on that. Let's look at the inverse of y equals 2 to the x graphically. So we looked at these graphs, or the graph of y equals 2 to the x in the last lesson, and I'm just going to run through and copy down what we had for the values from that lesson. So if we have y equals 2 to the negative 3, to get this value here, that would be the same as 1 over 2 cubed, which is 1/8. Okay, so we're just running through, repeating what we did from the last lesson, and we would get these numbers. And if we plot those points, we would essentially have these numbers. Okay, and then we can't plot 4, 16, but that's okay. All right, and if you need to pause your video at any time so that you can draw that, go ahead. All right, so that is y equals 2 to the x. Our exponential function, this should go right through 1 on the x-axis. Okay, good. Now, if we do the inverse, if you recall, we switch x and y. So notice the x from up here became the y for the inverse here. So therefore our y would become the x, and this value would be 1/8 for x, then 1/4, 1/2, 1, 2, 4, 8. That was supposed to be an 8. 8 and 16. Okay, so now let's graph that one and see what we get. I'm going to do that in a different color. You can too if you want. So when x is 1/8, yeah, that's going to be hard to plot, but somewhere really close down there. Okay, and when x is 1/4, y would be negative 2. So there we go. X is 1/2, y is negative 1. And we just keep plotting the rest of those. When x is 2, y is 1. When x is 4, y is 2. And there we go. Okay, now if we draw a nice, somewhat smooth line through those points, oops, at the very end there we can't cross that axis, so we got to make sure we don't do that. All right. All right. You guys having as much fun drawing this as I am? Okay, y equals, oh, sorry, we can't do y equals because we don't know how to do that yet. X equals 2 to the y. There we go. Okay, so there's our inverse function, and that makes sense. An inverse is a reflection over the line. What is this? I think this is one of the questions they're asking too. Okay, so I'm just going to draw that line. What is the equation of that line of symmetry? That would be y equals x. When you do the inverse, it's a reflection over the line y equals x. And there we go. Okay, so let's look at the next page and talk about our new term. So to be able to write this inverse function of the exponential function as y equals, we have to develop a new phrase, logarithmic functions. It's the inverse of the exponential function. And what's really funny is actually logs originally were developed first, like 500 years ago, as a way to deal with really large or really small numbers. So obviously a time before calculators. Okay, so generally speaking, if you have x equals 2 to the y, another way to write that would be y equals log, standing for logarithm, base 2. See that base there? It kind of comes from the fact that we had a base 2 here, and then of x. That's how we write that. Okay, and generally speaking, you'll notice, if you recall from the graph, our log function, the inverse of the exponential, looks like that. It never crossed the x-axis. So as a result, your x values always have to be greater than 0. Whatever's inside the log has to be greater than or equal to 0, because the graph doesn't exist on the y-axis or left of that. And also, your base on your function has to be a positive number and not equal to 1. Okay, so just to break down the parts of this log function, this, as I mentioned, is called the base of the logarithm. What's inside the logarithm, or follows it, I guess, is called the argument. It's kind of like the angle that was inside for trig functions, same idea. And what's over here is actually the value of the logarithm. Okay, so what is a logarithm? Well, we're going to find out. We're going to skip example 1 because it's very similar to what we have done before, plus it's similar to a question, and it's getting domain and range. Let's take a look at the next page. So this is just a copy of those table of values that we had from the first page, and they're getting into kind of what is a logarithm, right? Now the short version of what is a logarithm is it's the exponent. Okay, so a log, let's see if I find a place to write this. What statement can be made from the graph of that? So if you have, I'm just going to make a little note here, a logarithm is the exponent. Okay, but we have to add on some extra stuff. When the base on the log and the base on the power that's supposed to be the word power, is the same. Okay, so for instance, let's look at this first one, log base 2 of 8. If I was to write 8 as the same base as what's on our log, so 2 to the 3, so I've replaced 8 with 2 cubed, the log is simply the exponent. See that? So let's try the next one. What would we write 4 as if we wanted it as a base 2 power? That would be 2 to the exponent of 2, right? And therefore the log of base 2 of 2 squared would equal 2. The log is the exponent. Are you starting to get the hang of it? It's kind of weird, I know. Let's look at the next one, log base 2 of 2. Okay, it's already a power of 2. What's the exponent on that? It's a 1, so therefore the log is equal to 1, the exponent. All right, and the next one, a little bit trickier. Can we write 1 as 2 to some exponent? Let's think about that. Yep, special case. We could make that 2 to the 0, right? And therefore, what's the log of that? That would equal the exponent, which is 0. Okay, so writing, yeah, so that's the idea with logs. And we're going to do more of that in lesson 5 as well to kind of see where that could be used. Now there's a technique that you need to know how to do, and that's changing something from log form to exponent form. We're going to need that in equations, etc. So I'm going to show you, I'm going to do that with what we have here. Log base 2 of 8 equals 3. And I'm going to show you how I change it into exponential form rather than memorizing the base on the log becomes the base on the power, and what it equals is the exponent, and yada yada. We could just do the inverse operation, right? So logs and exponents are inverses of each other. So just like if you had something like square root of x and you wanted equals 3 or whatever, and you wanted to get rid of the square root to solve for x, you know how you would square both sides? Okay, that would undo the square root because square root function, quadratic, or a square function, they're the inverses of each other. Okay, same idea with logs. If we want to get rid of a log, I'm just going to write this off to the side, log base 2 of 8 equals 3. If I want to get rid of that log, I would do the inverse operation, which is exponent. Now, here's how I write that. I go 2 to the exponent of, okay? So really what I've done is I've raised both sides into the exponent, both sides of the equation into the exponent of 2 powers where the bases are both 2. Now why did I choose base 2? Because the base on the log was 2. You wouldn't undo a log base 2 by putting the power of 5 or something, just like you wouldn't get rid of a square root by cubing it. You'd have to get rid of a square root by squaring it, right? Okay, so what happens here is this undoes the log, and you're left with this. 8 equals 2 cubed. 8 equals 2 cubed. Okay, so that's where that's coming from. So try that with the next one. We've got log base 2 of 4 equals 2, and I want to change that to exponential form. So get rid of the log by raising both sides into the exponent, okay? And that would undo the log, and then we would have 4 equals 2 to the exponent of 2. Okay, don't go further with that. Don't write 2 squared as 4. We know that 4 equals 4. It's just we want it in exponential form, so that means having an exponent somewhere. All right, let's try the next one. If we want to change log base 2 of 2 equals 1 into exponential form, we undo the log, do the exponent. So that would undo log base 2, and we'd be left with 2 equals 2 to the 1. Okay, let's try it with the next one. Log base 2 of 1, undo the log, 2 to the log 2, undoes itself, I guess, and we have 1 equals 2 to the exponent of 0. And there we go. All right, so that's changing to exponential form. We'll try that later with some examples as well. If we have to go the other way, we want to change from exponential form to log form. What I do, and it takes a little one step longer, but at least it makes sense in my mind, we are going to log both sides. I'm just going to erase that so I can write a log in front of it. Okay, so I'm going to log both sides, just like you would if you're trying to solve x squared equals 2, you would square root both sides. Okay, now I can choose any base on my logarithm that I want. What I want to choose is whatever the base is on my power. So that would be base 2 on both sides. Now, if you recall, when you have log base 2 of 2 to the negative 3, the log is the exponent as long as the bases are the same. So then log base 2 of 1/8 equals negative 3. Okay, it's not that this cancels, it's just what is a log? It's the exponent as long as the bases are the same. All right, so let's write this one. Log both sides. Okay, base on the log, since the base on the power is 2, I'm going to choose 2 again. And there we go. We get log base 2 of 1/4 equals negative 2. Good. Okay, you guys try the next one. Pause your video. Okay, did you guys get log base 2 of 1/2 equals negative 1? All right, good job. Okay. I think we'll skip example 3. Let's look at the next page. So they've summarized the basic characteristics of the logarithmic function. If you recall, the graph looks like this. Okay, and we have an x-intercept of 1, just like with the exponential graph, we had a y-intercept of 1. Okay, there is no y-intercept because it will never cross the y-axis. Okay, so we actually have a vertical asymptote of x equals 0 here. Okay, and our domain, as you can tell from the graph, x is greater than 0, it doesn't cross 0, and y goes forever up and down, so that's our range. And yeah, so there we go. We kind of summarize our characteristics. All right, just remember you can't log 0 or a negative number, okay? Log bx is only defined for positive values of x. All right, let's take a look at finding the inverse of these functions here. State the inverse of the following functions. Answer in the form y equals. So when you hear inverse, you should think switch x and y. Okay, so y becomes x here, and x becomes y. All right, now we need to isolate y because they want it in y equals form. So look at y, it's inside the log. We need to get rid of the log then. You don't get rid of a log by dividing by it. You get rid of a log by doing the inverse operation, which is exponents. So bad grammar, we exponent it. Okay, so that would undo that, and we would end up with y equals 3 to the x. All right, let's do the next one. Switch x and y. We want to isolate y, which is in the exponent. How do we get at that? We log both sides. Okay, what base should we choose on our log? Well, base 8, because that's the base on our power. And then that just becomes y, and our answer would be y equals log base 8 of x. Okay, awesome. We're going to do the rest of this lesson in part 2 of the video. We will see you then.